Okay, suppose 2.6 mole of an ideal gas of volume V1 3.5 meter cube at temperature 290 Kelvin is allowed to expand isothermally to volume 2 7 meter cube. Determine work done by the gas, heat added to the gas, and also change in internal energy of the gas. Okay, good. So let's summarize what information given. We have the number of mole. Okay, ideal gas. We have the volume. Okay, V1 and T1, and we have V2. Okay, so we have two conditions. This is the initial conditions, and this is the final condition. This is important. So later on we should separate it into two. Separate into two sides. Yeah, initial and final. So we can put as this is as 1, this is as 2. Yeah, 1 and 2. Okay. So okay. Later we can put the information below here. Okay, in the initial condition, volume and temperature, pressure, or internal energy, and also the final condition, the second condition, the volume, temperature, pressure, and the internal energy, so on. Okay, so this is what kind of process. This is important. We say expand isothermally. So from here we know expand means volume increase. From here also we can know that volume increase is always work done positive. Do you know that? Work done volume increase is work done positive. Volume expansion is always work done positive. That's why work done by the gas. So the gas do work. The gas do work by pushing the piston up. So the gas do work done by the gas. Yeah, expansion. So if the gas do work means work done positive. So expand. That's why you say work done by the gas. Yeah. Okay, so we know work done is positive. Yeah, you see from V1 expand 3.5 expand to V2 7. 3.5 expand to 7. Yeah? Okay, isothermal process. This is isothermal process. This is important. Isothermal process. So what do we know about isothermal process? We should list down what do we know. Isothermal process. Let's look again. Isothermal process. What do you know about isothermal process? Isothermal process means isothermal. Temperature is constant. Temperature is constant. So when temperature constant, so only the pressure and volume changes. We have P1, V1, P2, V2. We can use the Boyle's law. And then delta U is 0. The change of internal energy is 0. So when we apply the first law of thermodynamic, it becomes Q equal to W. Okay. Where the graph is like this. Follow the isothermal line. Maintain at the same temperature. It's a curved line. So since it's a curved line, the work done, which is the area under the curved line, work done is the area under the PV graph. It's a curved line. So you get a formula nRT ln V2 over V1. Okay. To find the internal energy is F over 2 nKT. From temperature, given temperature, we can find internal energy. So these are the things we know. Okay. So okay, maybe you can write it over here. Yeah. Let's do some revision. So okay. Okay, so let's do sorry for a second. Okay, so now isothermal. Isothermal. So what do we know about isothermal process? Isothermal process. Oops. Isothermal process. What we know is iso temperature. So iso temperature means temperature constant. So when temperature constant, only the pressure and volume can change. Only the pressure and volume can change. So it is a Boyle's law. Okay, so since temperature is constant, so internal energy also become constant. Because why? Because the formula of internal energy is F/2 NKT. But see here, he gives us the number of mole. You see that? He gives us a number of mole. N. So this NKT, actually we can change to, because we know that PV is equal to NKT is also equal to NRT. PV equal to NRT, isn't it? So this formula also we can change to F/2 and RT, or even we can change to F/2 P1 V1, or also we can also change into F/2 P2 V2, because we have the two pressure, two volume. You see that? But the temperature is the constant. Only the temperature is constant. You understand? Of course, this number of mole and number of atom, also number of molecules, also constant lah. The temperature, important thing is the temperature is constant, but the pressure and volume changes. So we can also use this formula, or this formula, to find the internal energy at each point. Yeah, but internal energy is a constant. It's the same. Understand? So that means we can say we can actually say what is this? So since internal energy is constant, that means the internal energy at U1 is equal to U2. Okay, U1 equal to U2. Okay. Temperature 1 is the same as temperature 2. Okay. What else? I think enough. We can find the work done formula. Let's list down the work done formula is nRT. So what's the again? nRT ln V2 over V1. That's our formula. Work done is nRT ln V2 or V final over V initial. Enough, yeah. This is isothermal process. Okay, too much. So we apply the formula Q equal to delta U plus W. So since the I forgot to say, since the internal energy is constant, because temperature constant, so delta U is 0. So we can say delta U is 0. Delta U is 0. That means this can be cancelled. Okay, internal energy can be cancelled. 0. So become Q equal to W. Okay. Okay, Q equal to W. Alright, all the concept is here. So now, what do we have? We have the number of mole. Okay, write down, we have the number of mole. We have the number of mole. Okay, the number of mole, 2.6 mole. We have the volume, V1, T1. Temperature is constant because isothermal. You see that? Volume, the temperature is constant. Yeah, temperature 1 equal to temperature 2. So we can write here, temperature is the same. Temperature is the same. Which is what? Which is 290 Kelvin. But this volume 1 is he give us 3.5 meter cube. But this volume 2 we don't know. Volume 2 we don't know. Yeah, we have 7 meter cube. Okay. But of course this one, pressure 1, we also don't know. We can find it out. Okay, we can find it out. Yeah. we can use PV equal to nRT, you know, we can use PV equal to nRT to find out the pressure also. Okay, that's all. Okay, let me turn. Okay, I think you all know all this. You can continue already, yeah? You know all this, you can continue and try the question. Okay, let me show you step by step. So how to find the work done by the gas? How to do it? Question A, let's start with question A. So work done by the gas is, this is the isothermal process, isothermal expansion. So the formula is work done nRT ln V2 over V1. Do we have the number of mole? Yes, number of mole. We have the temperature. Yes, we have temperature. V2 over V1, of course, very easy. So we just use the formula nRT ln V2 over V1. V final, we can say this is like V final over V initial. Okay, it's like V final over V initial. Okay, so number of mole is 2.6 mole. R is 8.31. You can refer this value from the list of constant given in the exam. Temperature is constant. Temperature is constant for both conditions. T1 equal to T2, 290. So you can put this as 290 Kelvin. Okay, good. It's already in SI unit. Yeah, the temperature is already in SI unit. Remember this one, this chapter, all the temperature must be in SI unit, must be Kelvin. Degree Celsius not accepted. Okay, degree Celsius not accepted, it must change to Kelvin. Okay, so this one already in Kelvin, that's very good. Finally, ln V2. V2 is what? V2 is 7 meter cube, already in SI unit also. The V1 is V2 is this, V1 is 3.5. So put it as 3.5. Okay, let's calculate. Okay, so what answer do I get? Okay, so I got 43.08. 4343.08. Yeah, that's the answer. Joule. Okay, correct or not? Yes, 4343.08. That's correct. Good. Okay, and then what is the heat added to the gas? Okay, wait a second. Is this a positive work done or negative work done? Positive work done, I get a positive value. You see that? I get a positive value. So what does it mean by positive work done? Yeah, what does it mean by positive work done? Means is expansion. Yeah, indeed I get positive value. So it's work done by gas. Work done by gas. Or expansion. Volume increase. Okay, work done by gas. Work done by the system. Yeah, in fact it says work done by gas already here. You should get a positive work done. Because volume increase from 3.5 to 7. Okay, so now heat added. Why is it heat added? Why not heat loss? Why suddenly he say heat added? So let's heat absorb. Why not heat release? Let's check using the first law of thermodynamic, which is Q equal to delta U plus W. Let's do for question B. Q equal to delta U plus W. Since delta U is 0, because isothermal process is delta U is 0. So Q equal to W. So is our work done? Our work done is positive work done. Positive 4343.08 joule. What does it mean by the positive value here. What does it mean by positive Q? What does it mean by positive Q? Go back to our concept. What does it mean by positive Q? Positive Q means heat absorbed, heat added. You see the keyword absorb, added, supply or flow into the system or the gas. Okay. If heat released, heat loss, not added, heat loss, dissipated, flow out of the gas of the system, then Q is negative. If Q positive means heat absorbed, heat added. Q positive, heat added. So this is heat added. The Q positive value means heat added or absorbed by the gas. Okay, heat added, heat absorbed, or we can say heat gain, energy gain by the gas. Heat absorbed into the gas. That's why he say heat added. You see that? Heat added. So you get a positive Q. Okay, positive Q. So is that correct? The answer, yes, that's correct. Okay, that's correct. Now, okay. So the last question he says about what? What's the change in internal energy? Okay. For first question just now is work done. For second question, heat absorbed, heat added is Q. And this one, the last one is change in internal energy. That means delta U. I need to find delta U. So of course, this is isothermal process. Isothermal process is temperature constant, so delta U is always 0. So this is no-brainer. The answer is definitely delta U is 0 joule. Very easy. Yeah. Because why? Because internal energy is constant. Internal energy is constant. Because temperature is also constant. Temperature is constant. Yeah. So delta U is 0. Okay, that's the answer. Okay. So now I want to elaborate a bit about these questions. Let's say the question asks you to find the final pressure or the initial pressure. Do you think you can do it? Yes, of course, very easy. To find that, let's say I do question D. Let's say I want to find the final pressure. Final pressure, which is the P2. Very easy. So we just use what? PV equal to nRT. P equal to nRT. So remember this one is final pressure. So this P2 V2. Temperature is constant. Temperature is constant. So let's calculate and see what's the final pressure. Final pressure. So volume is 7. Volume is 7. Number of mole is 2.6 mole. 2.6 mole and R is 8.31. Temperature is 290 Kelvin. 290 Kelvin. Remember it must be in SI unit. Temperature. SI unit. Okay. So let's find out the pressure. Okay. So what's the answer? Okay. So the final pressure. Final pressure. So the final pressure is 895.11 Pascal. That's the answer. That's the answer. 895.11. You write into the information bank here. Easy to refer. Okay. So let's say I want to find initial pressure. Yeah. Let's say question E. I want to find initial pressure. Initial pressure, which is the P1. So how to do it? You want to use pressure what PV equal to nRT also can. Remember, the temperature is constant. This temperature and this temperature is constant because it's isothermal process. Temperature constant. Okay. So, or you can also use another formula like Boyle's law, P1 V1, P2 V2. See, you can also find the P1. You know, let's find out the P1. P1. What is the volume 1 over here? 3.5. 3.5. And nRT, the number of mole is still the same. The temperature is the same. Temperature for initial condition is the same as the temperature at final condition because isothermal process. Isothermal process. Let's find out the P1 over here. Let's find out. Okay. 0.6 multiplied 8.31 multiply 290 divided by 3.5. So I got the pressure is 1790.21 Pascal. Okay. If you want to use this Boyle's law also can, no problem. Okay. Let's try out maybe. Yeah. You surely get the same answer. You know. P1. What is the volume? 3.5. Because the nRT is similar. You know. nRT is similar, so you just equate this P1 V1 with P2 V2. So it's the same thing you do, yeah. Usually get the same answer as 1790.21. Okay, never mind. Let's work it out. As approved. Boyle's law, yeah. This is pressure 2, yeah. Just now volume 2 is 7. Let's calculate P1. Let's calculate. Yeah, let's calculate. So I've proven 1790.22. A bit different only because of round up the value. So you still get the same answer using this is what we call Boyle's law. You know, isothermal process is Boyle's law. You know that? Isothermal process is actually Boyle's law. Isothermal process. Isothermal process is actually Boyle's law. So that's the answer. Yeah, that's the answer for pressure 1. Is 1790.21 Pascal. Okay. Only the temperature is constant for isothermal process. Only the temperature is constant. But the volume and the pressure changes. This one, volume increase but pressure decrease. You see that? Volume increase but pressure decrease. From initial to final, volume increase, expansion. When expansion, you see that? When expansion, isothermal expansion, volume increase. Actually, the pressure decrease. Pressure decrease from this 1790 to 895. Pressure decrease. Boyle's law is actually Boyle's law. It's actually Boyle's law. When one increase, one decrease. Okay. So that's all for this question lah. Okay. So too lengthy of explanation, but all are facts. Yeah. All are points. So I hope you understand. Okay. Bye.